This is question 9 in test 6, section 2. So it says the table above gives values of the quadratic function f for selected values of x. Which of the following defines f? So just remember that these f of x values are like the y values when you input these x values. So one strategy is to just plug in the x values that they gave you and see if they give you the appropriate f of x output according to this table. And if you're going to use that strategy, I would strongly recommend inputting these x values because these are going to give you some more interesting answers compared to these. Because, 0, 1, and 2 have some strange properties where 0 plus 0 is the same as 0 squared, 1 squared is 1, and 2 squared is the same as 2 plus 2, so you're going to be much better off if you input the last two x values. Okay, so let's try that. So if we put in 2 as x, let's see what happens in the first equation. We get 2 squared plus 1, which gives us 5. So that works for this first one. Let's see what happens when we plug in 3 as x and see if it gives us 10 as our f of x. Okay, so we'd get 3 squared plus 1, which would give us 10. So this actually works for both of those. So what you could do to verify that this is the correct answer is you could plug in the remaining values here. You could check out if 0 gives you 1, which it does. 0 squared plus 1 equals 1. So this works. And does 1 squared plus 1 give us 2? Yes. Another way to go about this, so you can feel confident that is your answer, but another way to go about this would be to then try to see what happens when you input 2 as x in some of these other equations. So here you'd get 2 squared is 4 plus 2 is 6, so we know that doesn't work because it doesn't give us 5. And here we would have 8 minus 2, which would also give us 6, so that doesn't work. Here we would have 8 minus 1, which gives us 7, so that doesn't work. And 8 plus 1 gives us 9, so that does not work. When you plug in 2 here, you get 2 times 4, since 2 squared is 4, plus 1. So you could see that, therefore, A has to be the right answer.